Hello, Joker here. Welcome to the Joker's Book Review. Today's book is Twilight. I found this a very enjoyable novel myself. The plot of the book is very good. It starts off with Bella going to live somewhere that just sucks. And then she meets a vampire. And she falls in love because he's freaking awesome. I like Edward. I want Edward. His skin sparkles. I want him. Let me read you a passage out of the book. Edward, I love you. Bella, I love you. Ah, Edward. What? We're not doing a book review on Twilight today? What are we doing? What? What? No. Oh, but that's boring. Oh. Hello, Joker here. I'm here to tell you about Dalton's atomic theory. Dalton's atomic theory can be summed up in these 5 simple points. All matter is composed of extremely small particles called atoms. Atoms cannot be subdivided, divided, or destroyed. That is the law of conservation of mass. Atoms of different elements combine in simple whole number ratios to form chemical compounds. In chemical reactions, atoms are either combined, separated, or rearranged. With this atomic theory, Dalton made true the law of conservation of mass, the law of defiant proportions, and the law of multiple proportions. This is exciting, isn't it? Exciting stuff. The discovery of the electron. Yeah. First discovery of a subatomic particle resulted from the investigations between matter and electricity. These experiments were carried out with a cathode ray. Investigators noticed that when a current passed through a cathode ray tube, they hypothesized that that glow was caused by a stream of particles that they call the cathode ray. Scientists tested this hypothesis and they found out that the rays were deflected by some negatively charged object. This led to the hypothesis that what made up the cathode ray was negatively charged particles. And that hypothesis was strongly supported by some experiments done by J.J. Thomson. In one experiment, he was able to measure the ratio between the mass and the charge of the cathode ray. He found that the ratio was always the same. Thomson concluded that cathode rays are all composed of negatively charged particles, which he called electrons. He proposed the plum pudding model for the atom, which is like cookie dough. Okay, the dough is the atom and it's positively charged. And then the electrons are thrown in there like the chocolate chips and they're negative, of course. The discovery of the atomic nucleus. Huzzah! 1911, Ernest Rutherford and some of his assistants discovered the atomic They discovered it by bombarding a thin piece of gold foil with fast-moving alpha particles, which are positively charged. They expected slight deflection, like that. Okay, they expected slight deflection from the particles when they kept the gold foil, but they expected them to go through, okay? But what happened surprised them. Some of the particles did go through, but some of them went back. It's weird. They didn't think that would happen. Rutherford later said it was like if you shot a piece of tissue paper with a gun and it came back and hit you. After months of thinking, he finally came up with the explanation that the positively charged alpha particles must have hit some very powerful force within the atom. And he figured that space must be really freaking small because most of them went through and only some of them came back at it. He concluded the force must have came from a very densely packed bundle of matter with a positive electric charge. And he called this bundle the nucleus. Rutherford said that the volume of the nucleus must be very small compared to the rest of the atom. Rutherford proposed an atomic model. He proposed that electrons surrounded the positively charged nucleus like planets do the sun.
I love potatoes, I love potatoes, I love potatoes, I love potatoes.
One.
I love potatoes, I love potatoes, I love potatoes, I love potatoes.
Two.
I love potatoes, I love potatoes, I love potatoes, I love potatoes, I love potatoes.
He's bad. He's bad. He's gangsta. He's Onision.